Hello everyone, my name is Akshay Kumar. I'm a graduate student at University of Michigan-Dearborn, and thank you for joining me today. As part of the research paper presentation in the class ECE-528 Cloud Computing, I will be talking about the deployment of containerized deep learning applications in the cloud. This is an exciting and rapidly evolving field, and I hope to provide you with a brief overview of some of the key concepts and technologies involved. Before we get started, let's define what we mean by containerization and deep learning. Well, containerization is the process of encapsulating an application in a lightweight portable container that can run anywhere, while deep learning refers to a subset of machine learning that uses neural networks to analyze and learn from complex data sets. The cloud computing has got an increasing importance in several domains, where thousands of dedicated servers are set up to give the best services for their users on demand. In addition, these services are automatically managed by the providers, which require minimal effort for the users. As we know, deep learning models are incredibly powerful and useful in solving complex problems such as image recognition, natural language processing, and predictive analytics. However, deploying these models in production environments can be a challenge, especially when it comes to scalability, portability, and reproducibility. This is where containerization comes into play. It offers a number of benefits, including portability, scalability, and consistency. So, how do we containerize deep learning applications? There are a number of tools and frameworks available, including Docker, Kubernetes, Ansible, and Slurm. Let's talk about each of these in detail. Docker. Docker is a popular containerization platform that allows you to package your application and its dependencies into a single container. At a high level, the Docker architecture consists of three main components: the Docker client, the Docker daemon, and the Docker registry. Overall, the Docker architecture is designed to provide a simple and efficient way to package and deploy applications in a containerized environment. Kubernetes. What is Kubernetes? Well, Kubernetes is a popular container orchestration platform that allows you to manage and deploy containerized applications at scale. It represents a master slave type of architecture where each one outlines a various components. Master node is a set of services that administer and orchestrate the entire Kubernetes cluster. The master node components include Kube API Server, etcd, Kube Scheduler, and Kube Control Manager, while slave nodes are the worker nodes of the cluster that is controlled by the Kubernetes master. They can be virtual machines or physical servers. The slave node components include kubelet, kubeproxy, pods. Overall, the Kubernetes architecture is designed to provide a highly available and scalable platform for managing containerized workloads. Ansible is a popular automation tool that allows you to manage and configure multiple servers and devices from a central location. In the Ansible architecture, Ansible connects to the nodes and pushes out small programs called modules. These modules bring the systems to the desired state. Also, Ansible uses SSH to execute these modules and then removes them when finished. Ansible uses playbooks to implement the changes desired by the users. Playbooks contain plays, plays have tasks, and tasks called modules. Overall, the Ansible architecture is designed to provide a simple and flexible automation solution that can be used to manage a wide variety of systems and devices. Slurm. It is a simple Linux utility for resource management. It is an open source job scheduler and resource management system that is commonly used in high performance computing clusters. Slum has a centralized manager to monitor resources and work. There may also be a backup manager to assume those responsibilities in the event of failures. The Slum database daemon is used to record accounting information for multiple Slum managed clusters in a single database. The Slum REST API daemon is used to interact with Slum through its REST API. This section presents various cloud architecture and deployment approaches from the literature. Wagon proved that Kubernetes offers the automatic healing for failure actions, but using default configuration results outage in case of externally triggered node failures. Also, Shah mentioned that Kubernetes saves the cost and time because it is very efficient on scaling and managing stateless and stateful applications running in multiple hosts, comparing it with the Docker Swarm. Based on the study, Wettinger defined and characterized two deployment approaches: application oriented deployment and middleware oriented deployment. SaltStack is the tool used by Deshmukh to deploy the applications on different hosts. The proposed study also proved that due to the important time saved using this configuration, comparing it with similar system. The proposed infrastructure is composed of three physical machines, N1, N2, and N3. First of all, Kubernetes was deployed in the local cluster where N1 is the master node that manages all the containers running on the worker nodes N2 and N3. For suppose when a host fails, Kubernetes automatically restarts the failed containers to ensure the availability of the application. So in this architecture, Docker was used to containerize and deploy applications, which is the default container engine of Kubernetes. Thus, for provisioning, orchestrating, and managing the configuration of the infrastructure, Ansible is used. All the processes and configurations are managed by the master node, and no software is being installed on the remote host. So we don't need to set up the client server. At a given moment, the node may only be able to execute a limited number of tasks. In order to meet these needs, they used slurm technology to make and reserve the necessary resources for the proper functioning of each task. In order to make the infrastructure smarter and automate the deployment of applications in the appropriate node, a first analysis of deep learning applications was carried out in the next subsection. This study will allow us to integrate a script that will automatically assign the application in the appropriate infrastructure depending of its needs. Experiments were conducted using two machines, N2 and N3, described in the previous section. In the first step, they developed two deep learning use cases, fire detection and personal object, which is based respectively on image classification and object localization using the deep learning models. These applications are developed using Python as programming language, OpenCV as computer vision library, TensorFlow and Keras as deep learning frameworks. The first application, that is fire detection, is based on a classification model that used a deep neural network to detect the forest fires from the given images. The classifier can identify three classes. Those are fire, no fire, start fire. Start fire is nothing but smoke. To achieve this classifier, the following steps are being carried out: data preparation and annotation, model training, model test and evaluation. The second application, personal object, is based on object localization that used a deep neural network for the detection and localization of the personal objects such as keys, smartphone, wallet, etc. within the images. In the second step, for each application, they created and configured two Docker files, one for training the model and the other for testing the accuracy of the generated model. Each Docker file contains the software and required libraries to run the deep learning applications and analyze its requirement needs. For the third step, they started by analyzing the requirement needs such as RAM, CPU, GPU of each step of the deployed applications in order to limit the waste of the available hardware and allocate in a convenient and smart way, like only the suited resources for each deployed application. To analyze the requirement needs, they calculated the running time and memory consumption using CPU and GPU. For this aim, they used Python module for time calculation and memory profiler that analyzes the memory consumption line by line for Python programs. It also defines the high and low intensity parts of the program in terms of computation time and memory consumption. This figure shows the time computation and memory consumed using both CPU and GPU for the steps of training. We note that the use of GPU is very important for training deep learning models, which requires a high intensity of computation. They also extracted a part of the results between zeros and 400s because the execution time was very important when running in CPU. The use of GPU for training phase is highly recommended since it allows to reduce computing times by a very important factor compared to the CPU. On the other hand, we note that the use of GPU for test and inference phases requires a high consumption of memory compared to the CPU, with a negligible gain of execution, some few seconds. Table 1 shows in detail the results obtained during the training and test of the deep learning applications. Based on this analysis, they configured the platform to affect training for GPU and inference for CPU. To summarize, in order to deploy an application in the proposed environment, it will pass through several steps, such as before accessing to the cluster, we use the slurm to assign the user to the appropriate infrastructure according to its requirement needs. That is training to GPU and inference to CPU. And then create a Docker file in order to build a Docker image that groups the services of the deployed application. Finally, the master node will deploy the application as a service using Kubernetes command. The command follows as kubectl create-f configuration app.yaml. Here, the YAML file contains all the information about the deployment process. In this paper, they presented a cloud environment to deploy applications using the container technology that allows applications to be run in an isolated environment and facilitate the process of migration. They also proposed the infrastructure which exploits several technologies that makes it robust and safe. The platform is built using Kubernetes, Docker, Ansible, and Slurm to automate orchestration, deployment, and management of the infrastructure and the available resources. They also analyzed the requirement needs such as CPU, GPU, and memory of two deep learning applications based on classification and object localization. Well, their first results also showed that testing deep learning models on GPU is not recommended. This cloud platform is adapted for exploiting high performance resources, that is GPU, in addition to the standard resources CPU. As the future work, they plan to improve the process of application requirements by measuring more and more metrics and also deploying and other types of applications as well. This analysis will enable them to intelligently and automatically choose and assign high performance resources in accordance with the application resources. Thank you for your attention, and I hope you found this presentation informative. Please let me know if you have any questions in the comment section. Thank you.